Hello everyone, Amul here from the Target Common YouTube channel, and I'm here with another array based Java program. So I hope you people are liking my this series on programming questions in Java, and many people have requested me to share the code whatever I am writing in my Eclipse project. So yeah, sure, I will share that as well. So today in this video we are going to learn about the selection sort. Means we are going to sort an array using the selection sort. Okay, so let's get started. So if you see here, I have already one array where I have 5 elements like 11, 21, 7, 3 and 2. So obviously this array is not sorted. Okay, so if I ask you to sort this array, so your first question should be in which order. Means ascending or descending. Okay, so suppose if I ask you to do in ascending, so what should be the flow here? We should get first ascending means it should be increasing. So means 2, 3, 7, 11 and 21. Okay, so let me increase the size. Sorry, correct. So if we sort in ascending order, if I want to sort in descending order, then what should be the sequence? First I should get the maximum one, right? That is 21, then 11, then 7, then 3 comma 2, right? So this is called descending one, means we are starting from the greater number or bigger number and then we are decreasing it. Okay, and in the ascending order it goes from lower or minimum to maximum. Okay, so this is called ascending and this is called descending order. So whenever the question comes sort an array, so you need to ask first question in which order. Okay, so now we are clear. So for this program we are going to sort the array in the ascending order. Okay, means from minimum to maximum. Okay, here we have already sorted in ascending and descending order, right? So if you see here, okay, so what I'll do, I'm going to just remove the descending order because we're going to use the ascending only for this program. So if you see here, the first index, right, this consists of the smallest number from the array, right? And if you see the further, then it is like second smallest number from the array, right? And here is the logic, and by the name also selection. Okay, what actually we do in this selection sort, we pick the smallest or largest number based on sorting pattern. If you are sorting in ascending order, then we know that the first element should be the smallest one. Okay, so pick the smallest one. But if you are sorting in descending order, then we know that the first element will be the maximum one from the array. So you need to start picking the maximum number from the array. Okay, so in the selection sort, what we need to do, from the given array we need to identify the minimum or smallest number first. Okay, so out of this given array, so which is the smallest one? So we have the smallest one, number 2. So this 2 will be swapped with 11. Okay, this 2 will be swapped from 11, means 2 will come at the place of 11 and 11 will go to the last position. Okay, so after that we know that the first element is already sorted. Okay, then we need to find the smallest number again from the remaining array, means from the 21st. Okay, means at the beginning the array length was 5 and we found the smallest number as 2, right? And we put it here. In the second iteration, we need to consider only the remaining 4 elements. We need to ignore the first element because we know that element is sorted. Okay, so from 21, 7, 3 and here will be 11. So which is sorted, which is the smallest number? So it will be 3. Okay, and 3 will come at the first position. Okay, and 21 will come at the position of 3. So this is called selection. Means in the simple words, select the smallest number from the given array, and then simply ignore the sorted elements. Okay, so that we'll see in action now, so that you will understand it much better. Okay, so what I'll do, I will do first iteration, or we better name it pass 1. Okay, so we have this given array. So for this, what I need to for this I need to find the smallest number, right? So we have already done one program where we try to find the greater number from the given array, where we assume that the first number is the greater number, and then we started the comparison there. Same logic we're going to implement here. In the pass 1, we'll assume that the first index, sorry, zeroth index or first element of the array is the smallest one. Okay, that I am assuming. So let me put it 11. Okay, or okay, and I'll put index at 0. Okay, this I am assuming this the zeroth element, which is 11, is the smallest one. But this is just the assumption. I need to confirm, right? And how can we confirm that? By comparing from the remaining elements. So what I need to do here, I need to compare with the remaining elements like 21, 7, 3 and 2. So if you see here 21, so here we need to do a comparison here, like whether 21 is the smaller from the assumed one. Okay, in simple words, I need to check if 21 is greater than 11, sorry, smaller than 11, right? This we need to check. Then only we can find whether whatever I assume the smallest one, that is really in small or not. Okay, but 20 is not lesser than 11. So after first comparison, my assumption still remains correct, right? That 11 is the smallest one. Then the next element is 7. So I need to compare again. It's less than 11. Yes, this time we found another smallest number, that is 7, right? So the trick part here, we are not going to swap anything here. We'll just, what I will do, whatever we assume that index 0 is the smallest one, right? This time we simply will update the index only. Means that 0 is no more the smallest one. The smallest one is 0, 1, 2. Okay, 2 is the smallest one. Now what is the next element? 3. Okay, but our index element, it will change from 11 to 7, right? So what is the next element? 3. So here I have to compare whether 3 is the smaller than 7. Remember, now our assumed smallest number has been changed. Okay, so here the comparison, what I need to do, whether 3 is less than 7. Yes, 3 is less than 7. Then again at this time, what I want to do, we need to update the index. Means we have the smallest number at index 3. Okay, and the actual number is 3 only, right? Now what is the, again we have 2, which is the last element. So here in the last comparison will be whether 2 less than 3. Remember that since we are updating the index, so our assumed number will also change. Okay, so whether 2 is less than 3, yes, 2 is less than 3. Okay, then our final index will be 4. Okay, and the number will be 2. Okay, so we assume that at the 0th position we have the smallest number, which is 11, but after the comparison from by all the remaining elements, we found that no, our assumption is wrong. the smallest number is 2, which is at index 4. Okay, which is the number is 2, which is at index 4. Okay, so here now what is the final step? Like once the our assumption is wrong, then we need to do swap. Okay, swap of what? We will put the we'll put whatever we have at the 0th position, that I will put at this position, 4th one. Okay, and 4th one, which is the smallest one, I will put at the 0th position. So I will swap. After the first pass, we found where is the actual smaller number, at what index. That index will be swapped from the 0th index. Okay, so after this iteration, what element we will get? After this, what I will get? 2, then 21, then 7, then 3, then 11. Okay, so this is the final one. Now see, after this pass, our array is not sorted, so obviously we need to go for further pass. Okay, so what I'll do, I'll go for pass 2. So for the pass 2, we know that the first element is already sorted. We know that this is the correct. So do you think that do we really need to care about the first index? No. So for the next pass, we simply ignore this element. No need to use this one. So now we have only 4 elements from the array which are unsorted. Okay, so whatever we did in pass 1, similar things we need to do in for the remaining 4 elements. Okay, so here again, first thing, I will again assume that my the smallest number is again at position 1. Okay, if you see only the unsorted, then it will be 0, but yeah, just for the keeping the position in the sequence, now it is at the index 1, we have the sorted element, the smaller element, right? And element will be is 21. Okay, now what is thing? We need to start comparison, so that I can know whether whatever I assume that is that is really a smaller number or not. Okay, so from the next element, means from the 7, means all the remaining element we need to compare 7, 3 and 11. So I will not write like the first pass, but yeah, we need to see here. So whether 7 is smaller than the our assumed one, that is 21. Yeah, 7 is lesser than 21. Okay, so we found the new smallest number. So this time, no, 21 is not the smallest number. We have another one, 7. Okay, which is present at index 2. Now this now the we are at this position. So whether 7, which is the new smaller number, is or we can compare like 3 is lesser than 7. Yes, 3 lesser than 7. So we got another new smaller number, right? So it will be 3 this time. Okay, so there is no more small number, we have 3. Okay, and it resides as position 3 or index 3. Okay, so the last element is 11, and I need to compare whether 11 is less than 3. No, 11 is not less than 3. So after comparing all the elements, I found that no, whatever we assume the smaller one, that is not in real. The actual smaller number is 3. Okay, which is present at index 3. So since there is our assumption 0, so we need to do swapping. Swapping of what? So because we know that minimum element is at index 3, means here 0, 1, 2, 3. So this element will be swapped. Okay, at from this position, whatever we started from. Okay, we start from 1, because here in the past one we start from 0. So we did the swap of the actual index with the 0. Here we started with 1, right? Because the first element is already sorted, right? So we found that at the position 3 we have a smaller one. So this 3 will be swapped, means element at position 3 will be swapped with the element at 1. So what we will get here? 2. And what is at index 3? 0, 1, 2, 3. So 3 will come here. Okay. Then 7, and at the place of 3 we will have 21, then 11. So this is the trick part. We are not going to shift any element. We are just swapping with the actual small element from the assumed index element. Okay. Now this will be the end of pass 2. Now we'll go for pass 3. So after pass 2 we know that already two elements are sorted. Okay, means this element and these elements are sorted, correct? So remaining elements we have only 3. Okay, so you can see that after each pass we have a new sorted element. Okay, so let's start the same process whatever we did in pass 1 and pass 2. So for pass 3 our assumed smaller element will be at index 2. Okay, and the minimum element will be what? 7, right? Let's verify our assumption. So 21, right? Is 21 smaller than 7? No, right? 21 is not smaller than 7. So our assumed one remains same with the first comparison. Okay, let's go to the final one. 11, is 11 lesser than 7? No, right? Again, so at the with the pass 3 whatever we have assumed, okay, and after all the comparison we found that whatever we have assumed that is correct. So in pass 3 there will be no swapping and we will have the elements as 2, 3, 7, 21 and 11. Remember that we need to swap only if there is change in the assumption. If there is no change, then the elements will be as it is. Okay, so now we need to go for the next pass because still our is not sorted. But after pass 3 we have this much sorted element, right? So we have just need to sort these two elements. Okay, so for that what I need to do, I need to go for another pass. So pass is nothing like how many iterations we are doing, how many traces needed for to sort an array. Okay, so what do we need to do? Again the same logic, like the smallest element is at index 3, right? And the minimum element is 21. Okay, so we assume this one and we need to start the comparison here. And since there is only one element 11, so we need to check with the 11, like whether 11 is less than the assumed one, that is 21. Yeah, it is lesser. So we need to do swap, means the actual index where the elements resides, the small element reside, that is not 3 but 4. Okay, and the actual element is 11, right? So after this pass, means in the pass 4 we need to swap, means 21 will go at the place of 11 and 11 will come at place of 21. So means 2, 3, 7, 11 and 21. So now we have the sorted element in the ascending order. Okay, and this is called selection sort. By the name selection sort means you need to select, okay, minimum or maximum element based on your sorting order. Okay, so here we use the ascending order, so we started picking the minimum one and started putting on from the beginning, right? We have seen already. So now let's start driving the logic from here. So how many elements we had in the array? So we have a total 5. And how many iterations we required to do the sorting? So we required 4 passes, means we required 4 iterations to sort this array. Okay, so we got one logic. Okay, I need n minus 1, where n is the length of the array, to sort an array, minimum number of passes. So first logic, minimum passes will be n minus 1, where n is the length of the array. Another logic we have, after each pass we have one sorted element. For the pass 1 we need to compare everything. Okay, but for pass 2 our array length will be smaller. Okay, so this we need to keep in mind while writing the logic. So what I'll do, n element will be reduced. Okay, and we'll see how we can implement in the logic. Okay, how many comparison we required? If we assume that the first one is the sorted element, okay, first one is the minimum element, so how many times we did the comparison? 1, 2, 3 and 4, means we need to compare with all the elements. Okay, so if it is 5, if the length is 5, then we compare 4 elements, means the first one. If this if you pick this element, then we need to compare with the 3, means for any pass we need to go till the end. Okay, we need to compare with all the elements, all the remaining elements of the array. Third point will be compare with all remaining elements. And one point which is again important with the interview perspective also, and for the logic as well. If you remember in the bubble sort, okay, that I covered in my last video, if there is no swap happened, okay, during a pass, then we concluded that array is already sorted and we just terminated the loop, because if the element is already sorted, why we are going for remaining number of passes? Same thing here, if for any pass, if there is no swapping happening, if there is no swap happen, or the whatever we assume that is the actual one, so don't think that here we need to terminate the pass or terminate the for loop. You can see at pass 3 we have no swapping. Okay, no swapping happened in this for this pass 3, but for pass 4 it happened. Okay, so here don't confuse with the bubble sort. Okay, here in the selection sort, if no swapping is happening for any pass, that doesn't mean that array is sorted. Okay, you will need to continue till the last pass. Okay, so I hope that you are able to understand the logic, and once we have the logic we can write the program easily. So let's switch to Eclipse and write the code for selection sort. So here I have already created one array where I'm using the same elements for which I have given the demo here, right? So okay, so first thing we know that okay, so whenever you're doing sorting of array and also generally we require two loops, right? So here also one loop will keep how many passes we require to sort the array, right? And we already found that we required n minus 1 passes, right, or n minus 1 iterations, where n is the length of the array. So let me start with the for loop. Int, I will give the name as pass. Okay, and start from 0. That is always good if you are solving any array program. So always start from 0. So pass less than array dot length, right? But since we are starting the pass from 0, okay, so we need to do -1 here, right? Then pass plus plus. Okay, so if we have total 5 elements, so it will start from 0, 1, means length will be 5, right? So here array dot length minus 1 means 5 minus 1 4, pass should be less than 4 till there. So it will, if it start from 0, then 0 1 2 3, so total 4 passes for the array consisting 5 elements. Okay, now inner for loop will be responsible for the comparison, right? We assume the first one, then we start the comparison, right? So here let me start with j, or let me put I will start from which index? If we assumed that the first element is the smallest one, then we start doing the comparison from the next element, right? So here I value will be pass plus 1, right, from the next element, and after each pass we will have some sorted, so obviously it will go to the next element after each pass. Okay, so I will be pass plus 1. Okay, then again, since we need to compare with all the elements, right, all the remaining elements, so I will be less than array dot length. Okay, and then it will be increasing. Okay, so we are done with the inner loop, outer for loop and inner for loop. That is the basics. For the first pass, okay, for the first pass, what we are assuming that at which at like for the first pass we assume that 0th element is the smallest one, for the second pass first one, like that, right? So here we'll assume that at 0th index we have the smallest one, right? 0 will be represented by here pass. Okay, so for each pass the minimum index for assumed one will be automatically updated. Okay, I better let me name it assumed. Okay, so I assume that at the pass with the current position, okay, means current pass, okay, we have the smallest element. Okay, I simply try to put this logic for the first pass first element, for the second pass second element, for the third pass third element, same thing here. Okay, now what we do, we need to start the comparison, right? If what, if array of I, okay, means next element, okay, if the array of I is lesser than from array this value, okay, if it is smaller than, okay, if the next element is the lesser than the assumed smaller one, then in this case we need to update the index, update the assumed minimum index. Okay, we are not doing the swapping now. Well, what we will do, we will just simply update the index. Okay, so will be I, correct? So here if you see this diagram, so we are keeping the value also, right? So that was just for the demo purpose. If you are keeping the index, so automatically will fetch that value only, right? So that's why I simply updated the index only. If you found that at some index we have the smaller number, then I simply updated the assumed index one. Okay, so after this inner for loop iteration, we need to do swap. Okay, so here you can put a condition, if there is any index change then only do the swapping, but yeah, let it be. And what I'll do, I will swap the value. So I will use the third variable to do swap. So I'll store the value of pass here, and then in the pass I will keep the actual small element, right? I am just simply doing the swapping. Okay, Okay, so all logic is done here, and once we are coming out of this outer for loop, we can print the array. So I will not use any for loop to print, so we can use one class called arrays dot toString. Okay, and pass the array here, so it will print you the print the element. Okay, so let me run this program, and hopefully we can see it's proper, like 2 3 7 11 and 21. Okay, so let me change some numbers, let me put -1, then 45, then 1. Okay, and let me run this program. Okay, so -1 1 2 3 7 11 21 and 45. So our program is working fine. The logic very simple, just we need to make the logic in paper. Okay, then start writing the code, it will be easier for you. Okay, so if you have any doubt, please comment on this video, and if you really like my videos, please like, comment, subscribe and share with others. Thank you everyone.